Welcome back. Let's talk about the very first rule when it comes to big O. That is, worst case. When calculating big O, we always think about the worst case. What do I mean by that? Well, if we go back to Finding Nemo example. In the Find Nemo function, you may have been screaming at me while I was going through the function saying that, Andre, this is not efficient. What are you doing? Because if you look at this function, we're looping through the entire array to find Nemo. Remember how we had the everyone array with about 10 different characters from Finding Nemo? Well, Nemo was only the 1, 2, 3, 4th member on this array. And when we run this function, we found Nemo. But the funny thing is, this function ran 10 times, not 4 times. If I do a console log here, and I say running, and let's click this, we see that this function ran 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, we already found Nemo. All these runs are pretty wasteful. So we can make this function a little bit more efficient. In JavaScript, we can just have something called break. And again, different languages have different ways of exiting out of a loop if a condition is met. In our case, if we find Nemo, just break out of this loop. If I do this and click run, look at that. Once we found Nemo, we're done. We're not going to loop through the rest of the items. Congratulations, we just made our code a little bit more efficient. That's a good thing, right? Well, when it comes to big O, although this is important, and when you write good code, this is something that we want to do. In the big scheme of things, big O only cares about the worst case. What is the worst case here? Well, the worst case is that Nemo, instead of being the 4th item, is at the very end. So even if we have this break statement, we're still going to run this 10 times because Nemo at the end. Best case is if Nemo's at the very beginning and we only have to loop through it once. But worst case, we're still going to have to go through 10 loops. Still big O of n. So this is our very first rule. The very first rule is we always care about what is the worst case scenario, because when we talk about scalability, we can't just assume things are going well. Even though the Find Nemo function might be O of 1 if Nemo is the very first item in the array, it doesn't matter. In the grand scheme of things, because we can't be certain of what the input is going to be, we're going to assume that O of big O is O of n, linear time. Again, if we're finding a yellow box and the yellow box is at the very end, we have to iterate through all the boxes. If the yellow box is at the very beginning, you see that we don't have to iterate through these boxes. But big O doesn't really care. Even though this function, yes, is indeed more efficient, at the end of the day, when we talk about big O, we're talking about worst case. All right, I hope you got that point through. I feel like I've beaten it to a pulp, so you should be comfortable with it by now. Let's talk about the next rule in the next video.